Wow, it's great to see so many people here today. We've got a very good presentation for you. We'll be talking about what we're doing for database in the cloud, in the era of cloud and big data. We also have some demonstrations from Hitomi-san from Oracle Japan, who's going to show you some of our products, our latest innovations in action. Okay, so before we get into the content, just wanted to give you a big picture about what's been going on in the database space for the last 30 years. If you think about software technologies, most of them, they come onto the scene, there's a lot of hype, everybody's excited for a couple of years, and after about 5 years, maybe 10, everything dies down, the innovation goes to zero, and everybody forgets about them. They're still used, but not very exciting anymore. Relational database technology has been out there now for about 35 years, and the pace of innovation continues to accelerate. And the question is, why is this? And so the key thing that's been going on with relational databases is that there's this language called SQL. SQL gives you a declarative way of expressing what data you want out of databases. And it lets the database engine and the query optimizer sort of figure out how is the best way to process that query and give you an answer back as rapidly as possible. And so because of that separation between the language and sort of how you compute the results, customers have been able to write applications now for 30 years where those SQL applications have not had to change, but they've been able to take advantage of all the improvements as we go from one computing generation to the next. We went from mainframes to client-server to the internet, and now we're going to the era of big data and the cloud. And as we go through these generations, my developers have been innovating in the database engine to help to leverage all the latest and greatest technologies that have been coming along as we go through these computing eras. But the applications that have been written using SQL haven't had to change. They are just transparently taking advantage of the innovations that my group does to give them better performance, better scalability, better security, better availability, and they haven't had to rewrite those applications at all. And so that's the real secret around relational databases, is that we preserve the investment in SQL applications over 30 years, and we intend to do that for the next 30 years too. And so what we're going to talk about today is our latest innovations for cloud and big data. And I list some of them there, and we're not going to focus too much on Exadata. I think all of you know all about Exadata. It's been out for now about 6 years. It was originally invented as a big data technology for dealing with very large amounts of data, doing big analytic processing workloads in a data warehouse. And now, of course, it's moving into the era of big data. We'll talk about in-memory analytics, which is another big innovation in the big data space. And we'll talk about some of the innovations in the cloud space as well, like our multi-tenant capabilities. And we'll start with that, actually. As I said, over the last 12 months, the pace of innovation has been accelerating. And this slide just summarizes basically all of the products my group has delivered over the last 12 months. And as you can see, we're not restricting ourselves only to innovating relational databases now. We're actually innovating across a number of different data management technologies. NoSQL is an area that we are now working in. We have a very good Oracle NoSQL database product, very scalable, a highly available key value store. And we actually are now in production in Japan, running some systems on Docomo's internet applications. We're going to talk about Big Data SQL, which is a big innovation we're doing across relational database, Hadoop, and NoSQL technologies. We'll talk about in-memory database, cloud. One new thing we're doing, security, of course, is becoming very, very high on the list of priorities for our customers. And one of the things that's going on is everybody is encrypting all the data in their databases. And that means you've got potentially thousands of encryption keys to manage. And so we've come out with a product called Oracle Key Vault. And the objective is to Key Vault is to provide you with a very secure repository for storing and managing all of your encryption keys, which is now a really important priority for customers. And I'll talk about our latest engineered system, the Oracle Recovery Appliance, which we think is going to be of a lot of interest to many of you as well. Okay, so we have started 6 years ago building these products we call engineered systems, where we take Oracle's hardware server technologies and we integrate it with our database software technologies, and we deliver to you highly optimized platforms for running Oracle databases, and also for running our NoSQL database and Hadoop with our big data appliance. These products have been very successful, running all sorts of applications. I'll briefly mention that a little later. Our newest engineered system is the long name, which Larry personally named, is the Zero Data Loss Recovery Appliance. I like to just call it Recovery Appliance for short. And why did we create this product? Well, today, all of you are doing backups and recovery of databases. If some problem happens in your system and the data is corrupted or it's been destroyed in some way by some buggy application, you want to get your database restored back in time to before the problems occurred so you can continue your business. Now, the problem today is that these backup and recovery appliances that are out there in the market today were all designed for backing up and recovering file systems. They know nothing about databases. And so, although they can recover the database data, backup data, and they can store redo logs for you, they have no idea how that information is used to create a good new copy of your database as of some point in time. And what we are trying to do here is come up with a backup and recovery appliance that actually understands completely databases and can give you a foolproof, highly automated way of backing up and recovering your databases. So what are the key issues we're trying to address? Number one, data loss. With backup systems today, like I said, they'll back up a database as of a point in time, and then it's left as an exercise to the DBA to try to figure out how to get the database up to date. So you'll get a backup, maybe the backup was taken a week ago, and then the DBA has to find the right redo logs and roll them forward and get the database to the right point in time that the business really wants. Okay? Backup utilities typically have high overhead on the production database. They do a lot of I/O, they do a lot of CPU, they're backing up data to tape. And because of that, people have to create these backup windows, these times of day, usually in the middle of the night, when there's not much activity on the database, where it's okay to run your backup activity. Poor database recoverability. This is the problem I mentioned earlier. You have no idea, the backup appliances on the market today give you no assurance that you have the right database backups and redo logs to get your database to the point in time you want, because they don't understand anything about that. And finally, backup appliances out there today are not very scalable. They can back up a couple databases, and that's it. What we think customers want is backup recovery appliances. They can manage the backups and recoveries of all their databases in their data center. And so we've come out with this new engineered system, Oracle's Zero Data Loss Recovery Appliance. And the first thing this product does that's very unique is, as I said earlier, it takes not just backup information, the set of blocks being changed in databases, it's recording that, but it also is getting shipped in real time all of the row level changes in your database via the redo logs. So just like with Oracle Data Guard, for example, we are shipping in real time all the log records, the redo records from the production database to the backup appliance. And the backup appliance actually understands the relationship between the backup data that it's receiving and the redo logs. So it can make sure you have the right set of information to get your database restored to the right point in time. Minimal production impact. We are offloading a lot of the processing from the production database to the recovery appliance. For example, traditional backup systems require you to take a full backup once a week or so. This product, you take a full backup once, the first time you register your database with the backup and recovery appliance. You never have to do a full backup ever again, and those full backups take a lot of resources from your production systems. We offload backup to tape from production systems onto the backup appliance. That's another resource-heavy operation you do with backups. Fast restore to any point in time. As I mentioned, with the backup appliance, as a DBA, all you have to do is tell it, I want to be able to recover my database to, last week as of 5 p.m., Japan time. And the backup appliance will then gather, create a full backup, a full virtual backup for you, and it will give you the set of redo logs you need to bring your database back to that exact point in time. And it makes sure it has validated that all that information is correct and accurate and exactly what you need to do your backups. The other nice thing we do is that if you tell us you want to be able to restore to a point in time up to, say, 30 days in the past, as soon as that information that's needed for recovering, as of 60 days or 31 days is no longer needed, we throw it out. So all the old redo logs get thrown away, all the old backups get thrown away because you don't need them anymore. So we take care of a lot of the routine management of backups that you have to do yourself today because the current generation of backup appliances don't understand database. Okay? And finally, this appliance is built using Oracle Exadata storage technology. So it's incredibly scalable. You can scale out to petabytes of data. You can back up thousands of databases with this one appliance that scales incredibly well. Okay, so that's our new engineered system, the recovery appliance. So let's move on. Okay, so 12c is our flagship new version of the database. It came out a little over a year ago in 2013. And our big focus was cloud and big data, of course. And I'm going to focus in on a couple of the big features we did in the release. Of course, there's 500 new features in the release. We have no time to go over that in my presentation, but I'm sure in other presentations today you'll be able to hear about some of those. The big marquee feature we worked on for 12c was something we call the Oracle Multitenant architecture. And let me give you a little context for why we did this. So customers came to us about, this is 6-7 years ago, and they told us they really want to lower the cost of ownership around running their large numbers of Oracle databases. These were big customers. They have hundreds or even thousands of Oracle databases to run. And they were telling us, there are a lot of popular ways of doing consolidation to lower cost of ownership around running databases. You can use virtual machines. You can just run lots of databases on one physical hardware server. Or you can do this thing called schema consolidation, which requires you to merge together a number of separate applications. It's very hard to do without changing your application. And basically they told us, the most popular one is probably virtual machines. And they said, sure, I have 1,000 databases that are running today on 1,000 servers. And with virtual machines, I might be able to consolidate those 1,000 databases into 1,000 VMs and maybe run them on 100 servers. And that's really good because now I've saved a lot in my hardware. My hardware costs have really gone down. But what the customers told us is that, well, my big problem is still that before I had 1,000 databases that I had to manage. And now I still have 1,000 databases. They happen to be running in VMs, but I still have to manage them. So give me some way of lowering my cost of managing all these databases. And that's where the multi-tenant architecture was invented. And as you can see on the right, we created this feature called pluggable databases. And what we did basically was we took in 12c, we now have something called a 12c container database. And that container database now can hold up to 252 virtual databases inside it that we call pluggable databases. And you can think of this very similar to virtualization of hardware servers. You can take a hardware server and you can virtualize it into 10, 20 virtual machines and run applications in each of those. With 12c multi-tenant architecture, we have virtualized the Oracle database, and you can run up to 252 virtual databases inside. And so this is the key breakthrough customers were looking for, because now they can manage at the container level. So let me show you what I mean by that. So in this example, we have a simple 12c container database. It's got 3 pluggable databases in it, but you can imagine there could be 252 of them. And now you can do a lot of operations at a DBA at the container database level. So for example, if you want to patch all these 252 pluggable databases, there's just one binary that's shared by all of them. So you just apply the patch once, and now you've magically patched 252 databases with one push of a button. This is what we call manage many as one. Okay. You can do upgrades at the push of a button. The same thing, you just upgrade the binary in that one container database. There's also, if you have the different lines of business sharing this one container database, general ledger might be in one group, and the order entry might be a different business unit. They may not want to upgrade their database at the same time. So what you can do with 12c is you just can create a new container database for the new version, in this case 12x. It's empty. And then as the different business units are ready to have done their testing on the new release and they're ready to upgrade, you can do this new operation we have called unplug, where they can unplug their database, their pluggable database, from the current production container, running 12.1 in this case, and plug it into the new container. And that does the upgrade. It's a very simple, fast operation for upgrade. Unplug and plug. Okay? And so this, as you can imagine, makes the lives of our DBAs much, much more productive. Patching and upgrades may not be very sexy, but people spend a lot of time doing patching and upgrades. So this feature takes away a lot of the routine management costs around running Oracle databases. So what we're going to do now is run a video, and we have a number of our production customers using 12c Multitenant talking about their experience with the product.
Coming out of the recession, we really found ourselves in a position to turn the lights back on and really become an innovative team that can help the business move forward.
Specific issues we were faced with was things like being able to rapidly provision and deprovision testing environments for our customers.
When we implemented Multitenant, there were no application changes required to really connect pluggable databases back to the application.
Our consolidation ratio on database is about 5 times what we were looking at previously. We've been able to significantly reduce the time, effort, and therefore cost associated with standing up new environments, making clones for existing customer environments.
Our DBA currently supports over 40 pluggable databases. If these were standalone databases, he would be so busy he probably would have to hire at least another DBA.
We're able to give them new environments to both do volume testing and test new functionality within minutes of them asking us for it, whereas traditionally that might have taken a few days or perhaps even weeks for us to be able to stand those up for them.
We saved $1.7 million, and that is a huge amount of money to not spend on a project.
So, we started talking about consolidation, and one of the things one of the customers just mentioned is they are getting 5 times consolidation density with multi-tenant versus running standalone databases on the same server. So this is a huge potential cost of ownership savings. This is 5 times lower costs for running your databases. Big deal. Now, what are the big use cases for multi-tenant? Well, the big use case is what we originally called consolidation or private clouds, and now the popular word is database as a service. And one of the most common places people want database as a service is in their development and test environments. In fact, if you look at most typical customers, for every production database, they might have 5 or 10 copies or more of their production database in test dev. So what I've shown here is a simple example where we've created a container database for test dev purposes. And how do you use multi-tenant in that use case? Well, the first thing you do is you create a copy, a pluggable database that's a copy of your production system. And we actually have support for that in the product. You can just say, create a new PDB for me, new pluggable database, and make it as a copy of this remote database. And we will just do it all for you. We'll copy the data over and create the pluggable database for you. And that can take, the first thing to mention is if you are creating a traditional Oracle 11G database, it could take 20 minutes or so to create a physical database from scratch. With pluggable databases, you can bring that down now to on the order of a minute or so. Now, the other nice thing you want to do in test dev environments is you want to create clones or copies of production databases, because usually there's a number of different testers and developers and they want to try different things. And so pluggable databases have built into them an operation where you can say, create me a new pluggable database that's a clone or a copy of an existing pluggable database. So now what we've done here is we've shown a new pluggable database that's been created for the test developer. And that, as you can see, just took, again, about a minute or so. Now, a lot of you use copy on write file systems under your databases in test dev. So these are products like ZFS, Oracle ZFS, NetApp. These are also called snapshot file systems. And when you create a copy or a snapshot copy of a file, it actually doesn't do any work at all. It's just a metadata operation. And we can take advantage of that. And so in 12c, you can say, create a new pluggable database that's a clone of an existing pluggable database and make it a snapshot copy. And in which case, it takes virtually no time at all to make that copy. And so this is, I think, one of the primary things you should look at. The first thing you can do as you go to 12c is use it in your test dev environments as a way of creating database as a service for your test dev organization. And then the next thing to look at is look at this whole notion of a large database as a service offering that your IT organization can offer to all the business units. And this is where the real power of multi-tenancy becomes really clear. So what we show you here is a scenario where for database as a service, the IT organization is offering 3 different qualities of service that we have called bronze, silver, and gold. The bronze is that service we were just showing. It's for dev and test. It doesn't need to be as highly available. So we'll create one container database there on a single instance server, and we'll just do backups once a week. That's good enough for test dev. And that's what is represented here in the bronze area. And if I want a new test dev database, I can just go to a self-service website, fill in a few pieces of information about what I want, and it will provision me a new PDB in a matter of minutes, right? Okay, the next level up is silver, and that's where we start getting into production. And in this particular scenario, we're assuming for silver level, we want to use rack because rack gives me higher availability. And so we show a 2-node rack cluster here. And again, we created a multi-tenant 12c container database. And just like before, when the business unit says, I want to provision a new database, it'll just very quickly provision a new pluggable database to satisfy the needs of simple production systems. And then the gold level is for your most mission-critical databases in this organization. And there we're assuming not only are we going to have a container running on a rack cluster for the production database, but we're going to create a standby container as well on a standby database. And so for every pluggable database we create on the primary, we will create a pluggable database on the standby so we can provide disaster recovery as well. And here in this case, you can see we created 2 containers, 12c containers. One was created on for production on the primary database server, and the other container was created on a standby database server. Okay? So as you can see here, multi-tenant makes it really easy to deliver database as a service. And if you have a really big organization and you need more than 252 PDBs at each level, just create more containers. It's very easy. The other big use case of multi-tenant is for software ISVs. So I'm sure some of you in the audience are software developers who are building applications for your organization, and you would like to make them available on the internet as software as a service. So in the past, if you wanted to do that sort of thing, if you were like Salesforce.com, for example, you had to figure out how to do multi-tenancy at the application level, because you didn't want to create a separate database for each customer of Salesforce.com. A lot of the customers are very small. You know, they have 10 salesmen. So what Salesforce had to do is they had to figure out how to share big physical Oracle databases among all these small customers. With 12c multi-tenant, it's now really easy for any ISV to go to the cloud. You don't have to spend years building multi-tenancy in the application tier anymore, because we have now pushed it down into the database. And if you want to do software as a service, all you have to do is deploy one of these 12c containers. And then as your customers come in, each new customer is just allocated their own private PDB. And your application doesn't have to be rewritten. It just works out of the box. You can now bring your applications to the internet and become a software as a service provider. Oracle's Fusion applications are planning to use Oracle 12c multi-tenant. The first one has just gone production, Oracle Taleo, which is one of our human resources talent management applications, is now production on 12c multi-tenant. And we have some other SaaS providers as well that are production. SAS, the analytics provider, also is using a combination of 12c multi-tenant on Exadata to provide their analytics as a service product offering. Okay. And then finally, Sugihara-san talked a little bit about this earlier. Oracle announced at Open World that we are now in early limited production with our database and middleware technologies on our public cloud. And our intent here is very simple, right? We are going to make sure that any application, any database application you could write before on-premise can also be written or deployed on the cloud, or vice versa. So you can write applications on our public cloud using open standard languages like Java and SQL. You can then deploy them on-premise. You can move things back and forth. And this is, this sounds sort of obvious, but this is not the way things are working today on the internet. So Salesforce.com is a good example. With Salesforce.com, they have a development platform that used to be called Force.com. I'm not sure what the current name is. And you can build applications on their cloud. And everybody thinks this is really cool. But everybody is so excited about it, they sort of forgotten that, well, if I build this application on Salesforce.com's cloud, where can I run it? Well, I can only run it on Salesforce.com's cloud. I can't ever run it on-premise. I can't run it on the Amazon cloud. I'm completely locked into Salesforce. And so people have forgotten the lessons of the past where, portability to avoid lock-in is really important. And so our cloud is very different. Just like in the past where Oracle has let you run our database on every hardware platform and operating system you might want to use, and that gives you the ability to very quickly move from one vendor's platform to another. You want the same ability on the public cloud, and Oracle gives you that. You can now move your applications from on-premise to the cloud. You can move them to Amazon, whatever you want. It's an open standard platform, unlike what you will get from the existing cloud vendors. Okay, so just to summarize, we are very excited about Oracle 12c multi-tenant. We've invested years and years of development to re-architect the database for the cloud. We think we have by far the best, most powerful infrastructure for whether you're deploying database as a service on your own premise for a private cloud, or on the internet for software as a service, or for database as a service there as well. We lower your capital expenditure by being a much more efficient user of the hardware. We lower your management costs by letting you manage many as one, manage at the container level, and do things at the push of a button that patch and upgrade 252 PDBs at once. This is all transparent to your applications, so all those applications, again, that you've written over the last 25 years using Oracle SQL, they will continue to operate inside these pluggable databases because it's basically a virtualization technology. It looks and feels, a pluggable database looks and feels like a real Oracle database to the application. And of course, we spend a lot of time making sure all the existing features you want to use at Oracle work with our 12c multi-tenant architecture, things like rack and data guard, partitioning, etc. All those features work with multi-tenant. Okay, so that's the cloud part of the presentation. So now we're going to talk about big data. And what is big data about? Well, big data is simply about analytics. How can you leverage all that information out there about your products and your customers, some of which is in your transactional systems on-premise, some of which might be on the internet, on social networks, or some might be coming from sensors on devices in the Internet of Things, right? And so first we're going to talk about Oracle Database 12c in memory, and then we'll talk about a new exciting technology called Big Data SQL. Okay, so in-memory database is now one of those new technology areas, again, where we want to provide all the benefits of in-memory technology and performance to you without you having to rewrite your application. And it's, again, one of these transparent technologies where my engineers are going to do the heavy lifting and your applications for analytics are going to run 100 times faster. How can you refuse a deal like that, right? So the big goal here is that not only will this work well for analytics in sort of BI databases or data warehouses, it also is designed to work well against your live transactional data in your transactional systems. So the goal is 100 times faster, and as you'll see, sometimes you get more than that, sometimes you get less than that. It depends on your application. In addition, if you're doing transaction processing, this technology sometimes can help make that go faster too. And we will show you an example from one of our 12c beta customers where that was actually the case. But the sweet spot for this is really around analytics. It was not designed directly to make transactions go faster, but it does in some cases make those go faster as well. And again, as I mentioned earlier, this is transparent to your applications, just like we've been doing for the last 30 years. We are innovating in the engine, in the query optimizer, to give you much, much higher performance without you having to change your applications. Okay, so very quickly, I'll just explain this a little bit. So Oracle databases, have been around for years, and they are representing data in what we call the row format. Whether it's on disk or in memory, all the columns for a given row in a table are adjacent in memory, they're adjacent on disk, and this is really good for transaction processing. Why is that? Well, just consider inserting a new sales order into a sales order application. You just take all the columns for the sales order, you stick them in memory, you write them to disk in one I/O, you're done. Very simple, right? There's another way of representing tables in relational databases called column stores. And this basically turns the database 90 degrees on its side. And the idea is, instead of putting all the column values for a single row adjacent in memory and on disk, put all the column values for the whole table adjacent in memory or disk in what we call column vectors, as I call column vectors, as you can see in this example. So if you have a sales table and one of the columns is the sales amount column, all the different sales amounts for all the sales transactions will be adjacent in memory and potentially on disk. Okay? Now this kind of representation is pretty easy to see is not really good for transaction processing. Again, consider the example, I'm inserting a new sales order. What do I have to do to insert that new sales order? Well, if I have 100 columns in my sales order table, I have to update each of the 100 column vectors with this new sales order value. That's really expensive. And so column stores have been around for 30 years, but they've never been used very successfully in any kind of workload except a very analytic style workload, OLAP style workload. Okay? And what we are doing in 12c is we're saying, okay, so row stores are good for transaction processing. Column stores are really bad for transaction processing. They'll make your transactions run 2-3 times slower at least. But they're really good for analytics. I can in some cases make OLAP style analytics run hundreds of times faster. Okay, so customers today would like the benefits of both. They would like high performance analytics against their live transactional data. How do we give them that ability? Well, the other vendors in this market haven't figured out how to do that. They basically say, well, when you create your table, if it's for transactions, use the row format, and if it's for analytics, use the column format, and you can't get the best of both worlds. With 12c, we have a new way of introducing column stores into the database that we call the dual format methodology. And what we do is we retain on disk the row format for your data. And then the DBA, if he tells us that, oh, this table is could benefit from having column stores stored on it, when we bring your data into memory, we will not only bring it into the buffer cache in a row format, we will also on the fly create these column vector representations for your data in memory. Okay? And those column vectors are there for the purpose of making analytics go fast. So if all you're doing is pure transaction processing, your DBA won't even tell us to create the column store because it'll just make things run slow, right? Instead, if you're doing a mixed workload where sometimes you do some transactions, sometimes you want to do analytics against this live data, in this case, what you can do in 12c is you can drop indexes that normally you would have created for making analytics run fast against a row store, and you can replace them with these column vectors just on the columns that you want to run your analytics on. So if I have, say, 5 columns that I'm doing OLAP style queries on, the product column and the date column, I can tell Oracle, create column vectors in memory just for those columns. Okay? We don't create them on disk, okay? Just in memory. And that's a big difference between what we do and the other vendors. There's nothing on disk, so no changes to logging and recovery. There's no overhead for maintaining the column vectors on disk. And in fact, because we're replacing existing indexes with column vectors, that can actually make your transactions run faster because those indexes are maintained on disk and they're very expensive to keep in sync with the underlying table. So we create these column vectors purely in memory. When your query comes in, if it's an analytic query, the query optimizer figures out, I can use these column vectors to make this query run 100 times faster, and it just magically does it for you. Your queries go fast. You don't have to do anything, except tell us that these columns are important for analytics. Okay? And the really nice thing about this is that as you go to 12c and you adopt the in-memory technology, it's really easy. All you have to do, is upgrade your database to 12c. All the data that's on disk just stays the same way it is. We don't change the row format on disk. All you have to do now is have your DBA work with your application developer and identify the tables or even just the partitions of tables and the columns in those partitions that you want to bring into memory in these new 12c in-memory column vectors. And that's what we show here in step 1 and step 2. Step 1 says, allocate some memory for the in-memory column vectors to be stored in. Step 2 says, figure out which tables or columns of tables you want to bring into in-memory. And step 3 says what I was talking about earlier. If your application is like a lot of applications that's doing mixed workloads, analytics and transactions, you've probably created, 10, 20 indexes for making those queries and reports run fast. Well, now with this technology, you just drop those indexes. You don't drop all the indexes, the indexes for unique constraints and foreign keys. You keep all those. But the ones you've added to make your queries and reports run fast, you drop them and you replace them with column vectors on the columns that you previously had indexed. Very easy, right? And then now, as the data is being accessed by your applications, we will magically create these column vectors in memory for you on the fly. Very easy to deploy. You don't have to move to a whole new product and teach all new developer and DBA skills and all that. It's just very easy for your DBAs and your developers to pick up this technology. So the real proof is in the customers. I can tell you how great this technology is, but let's talk about a couple of customer situations. So one of our beta customers is Schneider Electric. It's a big electric manufacturing utility company in France, and actually they're a global company. They have a presence all around the world. They're one of our 12C beta customers, and in fact, they're very close to going production with an application, which is basically a data mart style application where they are pulling general ledger records out of their e-business suite application and using in-memory for that. And this just shows some of the results of their experiments. What these different columns are in the table are showing you, in gray, we show you how long a set of queries ran before using the in-memory technology. And the red shows you how long it took to run those queries after they started using in-memory. And as you can see in the three different examples, one with 2 billion rows, one with 300,000 rows, one with 30,000 rows, the performance gains were quite large, anywhere from 7 times faster to up to over 100 times faster. The other really exciting part about what they did was they were able to drop the analytic indexes that I talked about and replace them with column vectors. And that meant that now when they do inserts of data of rows into their data marts, they don't have to maintain those old analytic indexes anymore. And they were seeing 5 to 9 times faster load performance or transaction performance as well. So not only did they get the benefits that we talk about for analytics, they also got huge benefits for loading the data, the transaction part. And finally, because they were able to drop these analytic indexes, they saved 76% on the storage that they needed for storing their database. Because those indexes are on disk, they dropped them, they saved a lot of space there. The column vectors are not on disk. They're purely in memory. They cost nothing on disk. So this is a really exciting customer success story from one of our beta customers. The other thing we did, of course, is internally in Oracle, we build a lot of applications products. Sugihara-san had that slide from Open World where Larry was showing off all of our new SaaS applications. And so we've been working with all our application teams to take advantage of the in-memory column store technology. And this slide summarizes some of the results. And as you can see, these are what we call transformative results. If you can make cost management or supply chain planning run 100 times or 1,000 times faster, this is a big deal for your business because something that maybe used to take 2 days to run, now you can run it 100 times faster. You can run it in some 20 minutes. That means instead of sort of having to run a process that takes days or weeks, now you can run that process over and over again to better optimize maybe your cost management or supply chain interactively and do many more cycles and save huge amounts of money for your business. So that's why this technology is so exciting, not just because it goes fast, but because it can really change the way your business analyzes and uses their information. Okay. So in summary, we're very excited about this technology. It delivers very high performance analytics. We say up to 100 times, but as you saw in those examples, it could be 1,000 times. It's very much dependent on your workload, right? High performance analytics against your analytic data in a data warehouse kind of environment or a data mart, or against your transactional data in a more of a mixed workload environment. It's transparent to your applications. Once again, we are preserving your investment in your applications. All you have to do is work with the DBAs and figure out what analytic indexes you have in your applications. You can drop them and replace them with these column vectors. And finally, it's very easy to get to and deploy. You just upgrade to the new version of the database. You allocate some memory, some shared memory for the column vectors. And you optionally, of course, decide which columns to put in, column vectors to create. And then you can optionally drop some indexes as well. Very, very easy. No migration of data. Everything on disk is the same as before. All your existing Oracle features continue to work, like rack, data guard, etc. Okay, so with that, we're going to have Hitomi-san come up, and he's going to demonstrate actually 2 things at once. We're going to show our in-memory column store technology in action, and then we're going to show moving an application from on-premise to the cloud using our multi-tenant capabilities.
Thank you very much, Andy. ここから日本楽のひとみと申します。本日はお疲れ様ありがとうございます。これからですね、先ほどアンディが申していた通り、2つのデモをご覧いただきたいと思います。1つはですね、インメモリーですね。このオラクルデータベースインメモリを使うことで、今回39億件のレコード、データ量でいうと250ギガバイトのデータですね。これをどれぐらいのスピードで検索することができるのかというのを、インメモリ型および従来型のデータに対して検索してまいります。そしてそのインメモリーで動くアプリケーション、データベースおよび Java アプリケーションですね。このオンプレミスにあるデータベースとアプリケーションをそのままパブリッククラウドの方に移行していくわけですね。そして最後にパブリッククラウドに移行した後で同じアプリケーションがどのように動くのか、どれぐらいのスピードで返ってくるのかというところをご覧いただきたいと思います。それではまた画面の方を今度アプリケーションに変えますね。はい。こちらスクリーンに出ているのがですね、今回インメモリーのデータを検索していくアプリケーションですと。でどんなデータを使っているかと申しますと、実はウィキペディアですね。皆さんウィキペディアでいろんなキーワードを検索されると思います。これの検索したキーワード、いつ誰がですね、いつどんなキーワードが検索されたかというのをずっと貯めています。でこれ1週間貯めると実は39億レコードぐらいになるらしいですね。データでいうと250ギガバイト。これどんなものかとなかなか分かりにくいかと思いますけども、例えば日本の例で言いますと、例えばですね、都市銀行さんの場合ですと、例えば500店舗ある都市銀行さん、端末数が1万7000ぐらいある会社さんあるそうですね。でそれの端末で入力されるデータですね、記帳されるデータというのが実は10年間で 1.5 テラバイトだそうです。なので1年間でいうと約150ギガバイトですね。ですので今回対象にしているデータというのは1週間で250ギガバイトですので、1年間のデータでももっと多いものでございます。そういったものをこのスクリーンにはですね、上のところがその250ギガバイトをインメモリ上に展開しているもの、それに対しての検索をかけてどれぐらいのスピードで返ってくるか。なのでグラフヒット率ですね、1時間にどれぐらい検索されましたかというのはグラフでバーッと出てきます。で同じデータに対して、従来型のデータベースですとどれぐらいなのかというのは下に出てくるわけですね。でこの上の検索小窓にですね、今回はクラウドがメインのテーマですので、クラウドと言って、このボタンをポチッと押しますと上のところはものすごくスピードでバッと返ってきます。ですので、皆様目を離さないようにしていただければと思っています。じゃあこれから押しますのでぜひご注目ください。いきます。ポチッと押しました。で実際にですね、これ今どこで動いているかというと、弊社のヘッドクォーターにあるサーバーにアクセスしてきました。今上のところは一瞬でバッと赤く出てきたと思います。これが39億レコードに対してインメモリーに展開している、それに対して検索をバッとかけた場合ですね、下は今ようやく返ってきました。従来型のローフォーマットですと検索して結果が返ってくる、じりじり返ってくるわけですね。このまま投げてしまうと時間かかるので一旦止めてまいります。でじゃあ本当に同じデータなのかということで、もう一つだけキーワード、今回もう一つのテーマはビッグデータでございますので、ビッグデータに対しても同じように検索をかけていきたいと思います。また押しますのでぜひご注目ください。押しますよ。せーの、ポチッと。で、いきます。で、ちょっと時間かかりますね。ですけども、バンと返ってきました。で、先ほどのグラフと違うと思うんですね。検索キーワードによって、件数も変わってきます。そういった状況を、今、インメモリーと従来型のデータベースに対して検索をかけていたということでございます。で、実際にですね、今回のこの 250GB もプラガブルデータベースの中に入っています。ですので、先ほどアンディが申した通り、これをアンプラグして、他の環境に移してプラグインすることで、別の環境パブリッククラウドで動かすことができるわけですね。じゃあ、次はですね、このプラガブルデータベースを引き抜いていきたいと思います。でこれが皆様もおなじみの、エンタープライズマネージャーの画面です。これもオンプレミス環境を、マネージしているものですね。で実際にちょっと見づらいかもしれませんが CDB コンテナデータベースに対して3つの PDB があるというような、環境でございます。ですのでこれをポチッといきますと、ここにですね3つ PDB が移ってございます。今回は Wiki のデータを使ってます。この Wiki アップというデータベースを、アンプラグしていきます。ですので、これを選択しまして、アクションからこのアンプラグですね、アンプラグをすると、データベースを今アンプラグする準備になりました。いいよと。なのでこれから、データベースさまざまなデータファイルからなってますし、設定ファイルからなってますね。でそういったものをぐるっとまとめてポータブルな形にしていきますよっていうメッセージが来ているので、それを即時実行していくと。実際しばらく時間が経ちますと、この今はデータファイルをまとめているところですね、まとめてポータブルな形にしていきますと。で終了しましたと。 で実際に wikiapp.xml これが今アンプラグしたメタデータが入ったわけですね。これを新しい環境にも提供することでどんな構成のファイルだったのかどんなデータベースだったのかっていうのがよく分かると。はい、でここ見ていきますと先ほど3つあったものが2つになってます。アンプラグして1個データベースが管理下からない状況ですね。で実際に先ほどの 250GB をパブリッククラウドに送ろうと思いますと、結構時間かかります。ですので今回はですねデモンストレーションということで先に、送ったるファイルをベースに、プラグインという形で、パブリッククラウドの方に入れていきたいと思います。でこちらがですね我々のパブリッククラウドの、画面ですと。ですのでちょっとシンプルに、ちょっとログインしてまいります。でサインインとすると、ここでプラットフォームサービスということで一番上がデータベース真ん中がミドルウェア Java ですね。そして、コンピュートクラウドということでございます。でデータベースのクラウドの方に、ログインしていきます。でこの中見ていきますと実際にですね私が今このパブリッククラウドの中では、16の、仮想コアですねそれと240GB メモリー約 1.3TB のディスクを持っている。こんな環境に対して新しくプラグインしていくわけです。まだ先ほどのデータベースは入ってきてないと。ですので先ほどオンプレミス環境でエンタープライズマネージャーを使って抜きました。同じですねパブリッククラウドでも実はエンタープライズマネージャーを使いいただくことができます。でそれをもって、データベースを、プラグインしていくということですね。でお聞きしますとまだ CDB1 個あります。まだでもPDB は0ですね。ですので、この環境に対して、よっとログインします。ここもうちょっとお聞きしますね。ですので先ほど、エクスポート、アンプラグした、データベースをこちらの方に今度はプラグインしていくということでございます。はい、よっとでコンソール出てきますので先ほどの、wikiapp というものをデータベースをこちらの方にプラグインしていきますよとメタデータを渡してデータファイルを、このプラグインしていくと。でこの登録作業が、すぐ終わりますのでよっとポチッといきますとですね先ほど、オンプレミス環境から抜いた、wikiapp というデータベースがこちらの環境でプラグインされているというのがご確認いただけるかと思います。はいですね、で次はですね、Java のアプリケーションを移行していきたいかと思います。ですので先ほどもうデータベースの方はクラウド環境にすでにあると。で Java アプリケーションはデータベースより簡単でございます。Java アプリケーションはもう ID 環境である我々の、J デベロッパーから、プラグイン先デプロイ先をパブリッククラウドにするだけでデプロイできるんですね。でちょっと補足で言いますと我々のデータベースの開発ツールである SQL デベロッパーもオンプレミスもそうですけどもパブリッククラウドに対しても、ログインしてそこでアプリケーションエクスプレスなどの開発を行うこともできます。ですのでそんな、簡単に、先にですね本日は、アプリケーションだけデプロイしてますので、パブリッククラウドの環境で Java アプリケーションが実際に稼働しているかというところから確認させていただきます。ですので先ほどの、このクラウドの画面からですね真ん中のところが Java クラウドサービスでございますので、こちらの方にまた入ってまいります。いきますとインスタンスが1ということですでに Web アプリケーションが1つこの上で稼働してますよと。なのでコアとしては 2CPU ですね。あとメモリ 15GB があると。で、Java アプリケーションも同じくですねエンタープライズマネージャーこれもパブリッククラウドの中にあるエンタープライズマネージャーをお使いいただいて、動作確認だとか管理作業を行っていただくことができます。ですのでここで見ていただくとおり、オンプレミス環境でも皆様こういったエンタープライズマネージャーから監視されています。それをそのままパブリッククラウドでも、稼働しているということをこちらの方でご確認いただけるかなと思います。とはいうものの実際に本当に動いているのかいというところを、見ていきたくなるのが人の常でございますので今度先ほどデプロイしたパブリッククラウド上にあるデータベースパブリッククラウド上にある Java アプリケーションから、同じ検索キーワードで、確認していただいています。ですので同じく、クラウドですね、先ほどと同じです。このボタンを押しますとまたデータがバッと出てきますので、ぜひご注目ください。それでは押します。せーのポチッということですね。はい。ちょっと時間かかるかもしれませんが、同じように1時間あたり1200件の検索キーワードのヒットがあったと。で下の方もじりじりと、来てるわけですね。で同じデータですよということをもう一回示しますので、次にビッグデータですねこちらの方も、よいしょタイプしていきます。こちらも押していきますとせーのパチッと押すと、同じくちょっと時間かかりますけどもバンと出てきて先ほどと同じように1時間あたり約600件のヒットがあった。 こういった、環境をご確認いただけるかと思います。これが、オンプレミスからクラウド、パブリッククラウドに、移行したデータベースとアプリケーションで同じスピードをインメモリ、高速性能をインメモリで、ご提供できているということがご確認できたと思います。はい、デモンストレーションは以上になります。
Okay, thank you, Tomi-san. So in our last 10 minutes, we're going to talk about our final innovation that we call Big Data SQL. That is something that will, we think, really revolutionize the space of big data analytics. Okay, so before we get into the details of what that is, let's talk about SQL. SQL, of course, was originally part of relational database technology years ago when relational databases only dealt with structured data, like numbers and strings and dates. But 20 years ago, we, in version 8 of the database, we evolved the database to being an object relational database, and we added support for SQL access to unstructured data as well back then. We store essentially files in the database via lobs. We have special operators for doing text search, text processing, XML. We just recently added support for JSON in 12c, release 1, patch set 1. We have spatial graph analytics embedded into Oracle SQL in the database. Okay? So SQL is now a very powerful language. It's not just for structured data. It can analyze all your data, and you can store all your data, of course, in the Oracle relational database. So let's talk about the history very quickly of how did we get where we are today in this big data age. Well, we first started doing some analytics against our databases, our transactional databases, doing some operational reporting in the early days. Then people came up with this idea of a data warehouse. Let's take all the information from all our different transactional systems, store it in a data warehouse, and retain it for many years, so we have both integrated information across our systems, plus we have historical data where we can look at trends as well in the past. And of course, the Oracle database, technologies like Exadata are really good platforms for running your biggest data warehouses. They're now managing and analyzing petabytes of information in data warehouses. Well, now as we move to today, what's new? Well, there are new kinds of data people are looking at analyzing. Things like data from sensors, from the Internet of Things, data from social media about, your customers might be saying things on Facebook that could be useful for you if you're a big bank and you want to sell them some new retail banking products or something. So customers are now starting to create what we call data reservoirs, which are very low-cost file systems for storing lots of this new kinds of data, because a lot of that data doesn't have much value, so let's store it in some very low-cost place. The most popular new file system for doing that sort of thing is called HDFS, Hadoop Distributed File System. And so our big data management systems for doing big data analytics is now consisting of a big data warehouse, like an Oracle running on something like an Oracle Exadata, and sitting next to that is this big scalable file system that we call the data reservoir, now often running on Hadoop HDFS. And these systems are now being used to process all of your big data analytics. Well, there's a problem that has now arisen. So customers are now saying, oh, this is really good. I can store lots of information. I have petabytes of information in my Oracle data warehouse. I might have hundreds of terabytes or petabytes in my HDFS Hadoop file system. And I might even be using something like Oracle NoSQL database to store information also. And now I have this classic data fragmentation problem. All the information about my products and my customers is now scattered across these three data management repositories. And if I want to integrate that information together, it's really hard. They don't even support the same APIs. Hadoop classically supports MapReduce. They haven't historically had very good SQL there. Oracle, of course, uses SQL for the analytics. The NoSQL databases are very proud of the fact that they don't have SQL. How can you do analytics against them? Okay. So what customers want is they would like to have one simple Oracle SQL, we think dialect, SQL, that can span across all of their data management repositories. And they would like to leave the data where it is, because now in this era of big data, the amount of data in each of these repositories can be huge. And it's not always practical to just consolidate everything together in the central Oracle data warehouse, which you could do. And a lot of customers still do that. But some customers are saying, well, I have petabytes of information now in Hadoop. I can't just move it into Oracle. And the Oracle data warehouse has too much data to move to Hadoop. So I want to just leave it where it is and run a SQL statement that gives me fast interactive response against all that data. And so with Oracle, actually our new big data appliance in 12c release, we now support something we call Oracle Big Data SQL. And this, we think, solves this problem. You can now run a SQL statement from a BI tool, from your applications, using Oracle SQL dialect, and have that SQL statement integrate and join data across all of your data sources, whether it's in an Exadata database machine, Oracle database, or in a Hadoop cluster, or an Oracle NoSQL database. And very quickly, I'll just sort of show you visually how it works. So your BI tool, in this example, is issuing a SQL statement. It's sending it to Exadata. And on Exadata, we have the ability to make the tables in Hadoop and in Oracle NoSQL database look like they are what we call external tables in the Oracle database. And that means you can just write a SQL statement that references and joins data that's not only in Oracle database, but also in Hadoop and Oracle NoSQL database. And we are using the same tricks that make Exadata really fast for doing big data analytics. This technology on Exadata we call smart scanning. And that lets us move the processing of SQL down into the storage on Exadata. We're using this exact same trick to move the processing of the data stored on Hadoop and Oracle NoSQL database down into the nodes of the Hadoop cluster or the NoSQL database cluster on our big data appliance. So you can issue a standard Oracle SQL statement. It runs massively parallel across all these databases, and it gives you very high performance interactive query response, which is what we think people want now in this era of big data. And with that, we're going to call Hitomi-san up again, and Hitomi-san is going to demo this technology for you.
ご説明させていただいた通りですね、スタンダード SQL、皆様がアプリケーションを開発する SQL でビッグデータにアクセスしていくというところを見ていきたいと思います。で実際にですね、使う技術はビッグデータ SQL、これを使ってビッグデータアプライアンス上にある、ツイッターのデータですね、格納しているやつを取っていきますと。でそこから 12C の新機能である、JSON のネイティブサポートがありますので、ファイル上になっているものからエレメントを抜いてきますよと。なので、構造化を SQL でやってしまいましょうと。でそれとデータベースに格納されているデータを使ってアナリティクスをしていくと。で実際にですね、ツイッターデータとか使うときにはやはりセキュリティを気にすると思いますので、そういったものをオンザフライといいますか、リアルタイムでマスキングして情報が見えないようにしていく、こういった形ですねと。はい。よっと。ちょっと絵で見ていくと、同じような形ですね。なので HDF 上にある JSON のデータ、XML の形だとちょっとご理解いただければいいかなと。アノテーションエレメントがあって要素があって属性があるようなものですね。そこからデータをまずは最初そのまま持ってきます。なので1レコードで見えるわけですね。でもそれだけだとデータとしてはなかなか使えないですので JSON を使うことによってエレメント単位でデータを取ってくると。でそしてそれを売上データと組み合わせることによってツイートしている中で誰が自分の会社にとってインフルエンスがあるのかっていうのを見ながら、その方が実際に売上に貢献できているのかというのを見ていくとはいうものの、そういったデータを部門間かもしれないしいろんな企業に出すときには機密性を保たなきゃいけませんので不可視化ということを実際に見ていきたいと思いますですね。はい。で画面の方を切り替えまして、本当にスタンダード SQL だけでやるということで、今回はデータベースのアプリケーションの開発 SQL デベロッパーですね、こちらの方を使ってまいります。ここですね、見ていただきますと、ちょっと大きくします。はい、今回、ツイートというテーブルをデータベースの中から作っていきます。これはデータベースでいうとエクスターナルテーブル、外部表として扱っています。で外部表どんな形ですかというとオラクルハイブなんですね。 なので、ビッグデータアプライアンス上にある HDF 上にあるデータ群を、オラクルハイブというようなタイプとして外部表としてデータベースに登録します。ですのでオラクルデータベースから SQL を持ってアクセスできるようになるということですね。で実際にそれをアクセスするときにはパラレル64パラレル度数でアクセスしていくということで、並列度数を上げていくことができるとですね。はい、でここはもう簡単にですねよっと、テーブルをまず作っていくところから、既存のあるものを、ドロップしますと。はい、でそこから今、次のテーブルですね、これを作っていきますと。で順次ですねここら辺は、サクサクっていきますが今ちょっと SQL を実行しました。よっと作ったテーブル、すでにビッグデータアプライアンスにはツイートの情報が入っています。先ほどのツイートというテーブルに対して単に10件だけ取ってきなさいというふうに SQL を投げるとですねよっとちょっと待ってください、よっと下に結果が出てきますけども、先ほどのファイルと同じようにこれ1行に入っちゃってるんですね。なのでこの中から必要なデータを取ってこなければいけませんので、ここからですね、よっとここにある通り、SQL の構文ちょっとお聞きしますけどもキャストという、構文がございます。この先見ると T、ツイート、インタラクションとかオーサー、ネーム、こういったファイルの中のどのエレメントにアクセスしてくださいっていうのを投げてます。そうするとこのデータベースの裏で、ビッグデータ SQL に飛びます。でその中で JSON が動くんですね。JSON が動いてビッグデータ SQL のあそこのエンジンというか、パラレルの度数を使ってファイルから必要なエレメントを取ってくる。なのでエクサデータでいうとエクサデータのストレージサーバーでデータをストレージサーバーが取ってくるのと同じような仕組みがビッグデータ SQL でも動くわけですね。こういった負荷のプッシュダウンをしているということでございます。で実際にこれをしていきますと、よっとちょっと見づらいですけども、パッと結果が返ってきてるわけですね。でここで何を示しているかというと、ツイッターにツイートしている中でどんな、記者さんだとかどんな人がよくツイートしているのとどんなインフルエンスがありますかっていうのが K ロットということで、98とか97ポイントが高い方がインフルエンスがある人ですよ、こんなデータが出てきていると。でこういったデータに対してですね次は、売上データを掛け合わせることで影響力のあるよくツイートする人が本当に売上に貢献できているのかと貢献していただけているのかっていうのを、示していきたいと思います。で実際には今回は、出てきたこちらのデータですね、よっとどれだけ売り上げているのかと、ご購入いただいているのかっていうのが、ユーザー名だとか、シティ、ご住所ですね、あとユーザーネーム、そして、これまでのライフタイムセールスですね、購買履歴の集計データなどが、含まれているようなデータでございます。で実際に、こういったデータを、組み合わせていくわけですね。で実際に先ほどのツイート、が入っている、ビッグデータ SQL にアクセスするテーブル、それと先ほどの構造化データですね、カスタマーとそういったデータも組み合わせてセレクトしていく、計算していくようなことをしてまいりますと。はい、でこちら次出てまいりましたのが、組み合わせてきていくまだこの元データですね、とはいうもののこのリラティブセンティメントということで実際にこのユーザーさんが例えば売ってるビデオだとかムービーだとかそういうものに対して好きか嫌いかっていうのがあります。でそしてその横のカラムにあるのが、コントリビューションという、レベニューコントリビューションということで売上の貢献度合いですね。なので両方のポイントが高い人というのが、影響力もあって売上にも貢献いただいているっていうビジネスに貢献しているとこういったものを示しているような、データでございますと。で実際にこうすることですみませんさっき言ってましたね。売上のデータ皆様のお客様がどれぐらい自分の会社が好きか嫌いかそれがどれだけ売上に貢献しているかというところまで見えました。で実際にこういった情報というのはマーケティング部門だったり製品の開発部門だったり営業部門に情報を共有していったりあるいはパートナー企業さんに共有していくことがあるかもしれません。でそういった時にですねデータがあまりにも見えてしまうと良くないことがあります。お客様の名前かもしれないし住所かもしれないし、生年月日ですねそういったものをマスキングしていきましょうと。とはいうもの実際のデータを変えずに検索して、返すとき画面だったり他のデータアプリケーションにつなぐときそういったときだけ、見えなくする技術これが我々のデータベースの中の機能でリダクションという12Cの新機能がございます。それを、かけていくんですね。 でそれはシンプルで、どのテーブル、どのカラムに対してどんなポリシーでマスクをかけるのかかけないのか、そういった、ポリシーを定義していくことで、動的にですね、データを不可視化、あるいは不正示化することができますので、そのポリシーを設定していきたいかと思います。はい、こういった形でですね、これも PLSQL のブロックを使って、ポリシーをいくつか設定してまいりますと。ここですね。はい、で今回はよっと。2つほど設定した後で、先ほどのクエリをもう1回今度はエクサデータにつないでいきたいと思います。ちょっと時間かかりますけども、はい、今もうちょっとお待ちくださいね。実際にこれもオンザフライでデータベースにアクセス、データベースからビッグデータ SQL にアクセスしに行って、そこからデータを、JSON で中身を取ってきて構造化データとジョインして、で返ってきたうちのデータのうちユーザーネームだとか、あとはアドレスっていったものを、その返ってきたデータに対してマスキングをかける、あるいはリダクションをかけることで、個人情報がわからないようにしていく。なのでビッグデータ、これからどんどんビジネスの中で使えていく中で、大量のデータをリアルタイムで取ってくること、そして取ってきたデータのセキュリティ、データアクセスの、機密性ですね、これを守っていくということがすごく重要になってくると思います。でそういったことをですね、すべて SQL ベースで行えるというのが、アプリケーション開発の効率も上げていくということになります。こういった、そういったところですね、デモで本日はご紹介させていただきました。はい、デモンストレーション以上になります。
Okay, thanks, Hitomi-san. So we're just going to close now and just summarize what we've been talking about. We started talking about how we're innovating to let you preserve your investment in your SQL applications technology and your BI tools and database skills. And give you the benefits as we move to the new computing eras, like the big data era, the era of the cloud. My group is now innovating not just in relational database technologies, we're also innovating in technologies like Hadoop and NoSQL. We just saw Hitomi-san's demo of Oracle Big Data SQL, which we think is a huge innovation for customers who want to do big data analytics across all their data, no matter where the data is being stored. Of course, we're continuing to innovate in our engineered system space as well. You saw the new recovery appliance technology earlier in the presentation. In-memory database, we're just at the beginning of in-memory technology. This is going to be another big area of innovation for the next 10 years at least. And of course, the cloud, we are moving into this era of the cloud, whether it's private clouds on premise or public clouds on the internet. We see that as a big trend that's going to happen over the next, this could happen over the next 10, 20 years as we transition from completely on-premise to, maybe hybrid, part on-premise, part on public clouds. And we showed you Oracle's multi-tenant architecture in 12c, where we think we have done a really innovative job of creating multi-tenancy in the database itself. You don't have to do it anymore in the application level. And that gives you, again, the ability to move your applications to a cloud. If you're an ISV, offer software as a service without any work at all. You just run your applications in our pluggable database, and you're off and running, and you can deliver software as a service on the cloud. So with that, I'd like to close, and thank you for coming.